Hello everyone, my name's Dr. Vile and welcome to my YouTube channel for A-level chemistry. The purpose of this channel is all about getting you ready for your A-level chemistry exams. And in this particular video, we're going to focus in on an organic mechanism that you need to know for A2 chemistry. And the mechanism is called nucleophilic addition. So we're going to have a look at the reaction and we're going to try and understand the curly arrow mechanism that explains why this reaction proceeds the way that it does. If you find these videos helpful, please like them, please subscribe to the channel, please check back regularly for more content. So let's have a look at this reaction, nucleophilic addition. So I've tried to give an example where we look at the reaction of an aldehyde with hydrogen cyanide. So what we'll do is we'll look at the reaction as a whole first, and then I'll try and talk you through the mechanism. So when you have an aldehyde, let's just say R, where R is the rest of the molecule that we're not particularly interested in. And then you have an aldehyde group, which is C double bond O, and then a single bond to H. And if you react that with, let me draw some colours here to try and show you, H in red, and then cyanide in green, so CN. And I've deliberately chosen colours here, and we'll have a look at that in the product. You still have your R group that is bonded to a carbon. The double bond becomes a single bond, and it's bonded to the O that was there already. But now if I go back to red, that's an OH group, an alcohol. You've still got the bond to hydrogen that was there originally, but now we've got a single bond to C triple bond N, which I show in green. So we call this a hydroxynitrile, where the OH group is the hydroxy and the C triple bond N is the nitrile group, so a hydroxynitrile group. And the mechanism we said was nucleophilic addition. Hopefully it's obvious as to why this is addition, because we're adding the hydrogen and the cyanide across this double bond. But maybe we don't quite get why it's nucleophilic addition. We'll see that when we look at the curly arrow mechanism. So nucleophilic addition. Let's get into the curly arrows now and I'll try and talk you through why this happens. By the way, you need to know this mechanism for the reaction of hydrogen cyanide with both aldehydes and ketones. So hopefully we can see that on the consequential slides. So let's try and get into the curly arrow mechanism. Start off by drawing out your aldehyde. Just as a little note, for your A-level paper, you're not going to have R like this. You'll have to draw it for a specific aldehyde, but the principles of how we do the curly arrows remains exactly the same. And the first thing to note is that this carbon double bond to oxygen is polar, where the carbon is delta positive and the oxygen is delta negative, and that's because oxygen is more electronegative than carbon. Now hydrogen cyanide, HCN, is an acid and it dissociates into H plus ions and cyanide ions, C triple bond N minus. And it's this cyanide ion that's going to act as the nucleophile. So if I draw it out, C triple bond N, and we know that the negative charge is on the carbon. And the reason that we know that the negative charge is on the carbon is because it forms a new carbon-to-carbon bond. So your first curly arrow goes from the negative carbon to the delta positive carbon. Now this is what we call a bond-forming curly arrow. The electrons on the carbon here are being used to make a new bond to the carbon. And then this double bond breaks and both of the electrons, both of the bonding electrons, move on to the oxygen. And what forms as a result of this is you've got your R group bonded to the C, bonded to the H as it was before. The double bond has now become a single bond to oxygen. And because we've moved a pair of electrons from the double bond onto the oxygen, this oxygen becomes negatively charged. And then we've got a new bond here to another carb, to the carbon of the cyanide, C triple bond N. And then all that happens in the last stage is that the H plus ion, remember this H plus ion from here? The O minus is attracted to the H plus. And that should be in colour, let me get that right. And you end up with your hydroxynitrile, R to C to OH to H to C triple bond N. So, two key things. Why do we call this addition? Well, because all of the atoms of the hydrogen cyanide add across the double bond. The atom economy of this reaction is 100% because there's no wasted atoms, there's no side products. So it's addition. And it's nucleophilic addition because this cyanide ion, C triple bond N, is acting as a nucleophile, which is something that is negatively charged that is attracted to something positive. So nucleophilic addition. Now you may ask to do the same reaction but for a ketone rather than an aldehyde. And good news, it's lovely and simple to do. Let's take a real example this time. Let's take propanone. C double bond O to CH3 to CH3. You're going to be pleased to know the mechanism is almost identical. And here comes your cyanide ion, C triple bond N, with a minus charge on the carbon here. We put our dipoles on to show the polarity of this double bond. And then the curly arrow, same as before, from the negative charge on the carbon to the delta positive carbon. Make sure your curly arrow is going in that direction. And then the double bond breaks with both of the electrons moving onto the oxygen. Draw out the consequential intermediate. And then along comes our H plus ion, same as before, and the O minus is attracted to the H plus. Just a couple of things about curly arrows while we're here. Firstly, curly arrows always go from negative to positive, so from somewhere with lots of electrons to somewhere that is electron deficient, never the other way around. And there are two types of curly arrow, bond forming curly arrows and bond breaking curly arrows. So if we look at the curly arrows we've drawn here, this first one here, this is a bond forming curly arrow, forming a new carbon to carbon bond. If we look at this curly arrow here, this is a bond breaking curly arrow because the double bond is breaking and we're moving the electrons onto the oxygen. And then lastly, this curly arrow over here is forming a new bond between the oxygen and the hydrogen. And just for completion, the product from this would be C to OH to CH3 to CH3 to C triple bond N. Now, you might ask me about the naming of this compound. Well, what you do is you count the longest carbon chain that has the nitrile group in it. So we treat this as carbon number 1, this is carbon number 2, and therefore this is carbon number 3. And then we would say that this name is 2-hydroxy, because you've got a hydroxy group on number 2, 2-methyl, propane nitrile. Okay, so we count the longest carbon chain containing the nitrile group, call that propane nitrile, and then treat everything else as branches. Thank you for taking the time to watch this video. I hope it was helpful. If it was, please like it, please subscribe, keep coming back for more videos, and I'll see you on the next one. Thanks very much, everyone.